This is Algebra 2 with Trig, Unit 1B.2. We're going to graph using intercept form. What we remember from past lessons is that y equals a x minus h quantity squared plus k. That is our vertex form of a quadratic equation. Today we're going to talk about intercept form. Y equals a x minus p x minus q. So now we are factored apart. We have two quantities with a p value and a q value. And those p's and q values are your x-intercepts. So we call this intercept form. We know that the graph of the we're going to graph the x-intercepts and the vertex. The x-intercepts are the p, 0 and the q, 0. So they are going to be the opposite of what's inside the equation again. All year it's going to be like that. So this is x minus p, so we take the p value, x minus q, so we take the q value. Now this part's different also. If we have our x-intercepts, we know that our line of symmetry that cuts the shape right in half is going to lead right to the vertex. So that line has to be halfway in between. So the x-intercepts of the vertex is halfway between the x-intercepts. The x-coordinate is halfway in between the x-intercepts. So we're going to use x equals p plus q divided by 2. That is our formula for finding the line of symmetry. The vertex is on the line of symmetry. So that helps us find the x value of the line of symmetry. We're going to substitute our x value for that line of symmetry back into the original equation. And that's going to give us the y coordinate. That's going to give us our max value. That's going to give us our minimum value by plugging the line of symmetry back in. We know that a graph is going to open up, which is going to make it have a minimum value. Whenever the a value is greater than 0, we know that the parabola is going to open downwards. So it's going to look something like that. It's going to open down, which is going to make it have a max whenever the a value is less than 0. The a value cannot be 0, so that's why we don't say equal to. It's got to be greater than 0. It's got to be less than 0. The a value won't be 0, or else you don't have an x squared quantity. So here's a video of our process that we'll be working on, if you would care to see that. But we're going to talk about graphing in intercept form. So we know that our formula is y equals a x minus p x minus q. So I know that my p value is 1 and my q value is 5. It's going to be opposite of what's inside the parentheses. So my coordinates are going to be 1, 0 and 5, 0. P comma 0 and Q comma 0. So those are our X-intercepts. And our vertex is somewhere along this line. But we're going to calculate where that line is. I kind of drew it in, maybe because it was so simple to find. But our vertex is on the line of symmetry. To find that line of symmetry, we would say P plus Q divided by 2. So 1 plus 5 divided by 2, 6 divided by 2, which is X is 3. So we label our graph X equals 3. Now our notes told us to take that line of symmetry and plug it back into the original equation. Y equals -2. If X is 3 minus 1 and 3 minus 5, that gives us -2 times 2 times -2, which is a total of a positive, I wrote negative, a total of a positive 8. So there's our vertex. We knew it was on the line of symmetry. We figured out that line of symmetry was X equals 3. And we plugged in the 3 to figure out just what the Y value was when X value is 3. So our vertex is 3, 8. With an axis of symmetry of 3. It's going to have a maximum value where the Y value is 8. We know that domain is all real numbers, and the range of values is less than or equal to 8. So let's talk about drawing our line in here. We could just estimate and draw that in, but if we think about it here, we went over 2. Usually 2 squared is 4. 1, 2, 3, 4. We usually go to here. But we're going twice as far because the A value is 2. So instead of going 1 and 1, because 1 squared is 1, we're going to go twice as far. We're going to go to 2 because it's twice as far because the A value is 2. That just allows you to have a better estimation of how your graph opens up. In this case, opens down. So Y equals -2, X minus 1, X minus 5. In our end behavior, as X approaches negative infinity, as you plug in smaller and smaller and smaller numbers, you're going to get Y values that are smaller and smaller. As you type in bigger numbers, you're going to get Y values that are also smaller. There might be a time where you get some positive numbers, right, where the vertex is at, when you're near the vertex. But anything very far out to the sides, you're going to get very negative answers. You can see that in the graph. So you pause the video now, and you try this one on your own. we look at our graph here, we know our equation is A x minus P, x minus Q. So our P value is going to be -3. Our Q value is going to be -5. So we're going to have x coordinates of -3 and -5. So our line of symmetry is going to land halfway in between that. So we have -3 plus a -5, which is -8 divided by 2, which is -4. And that's, of course, what I've sketched in here already. I knew it was halfway in between the vertices, but be able to support your work. So now we're going to have y equals 3, -4 plus 3, -4 plus 5, 3 times -1, that's a -3, times 1, that gives us a -3. So at -3, we're up here, actually down here at negative. When x is -4, we're down here at -3. So our vertex is -4, comma, -3. Axis of symmetry is -4. That's going to make us have a minimum value and remember, minimum values are always y values. So we write the equation of our graph. 3x plus 3, x plus 5. We, of course, know the domain is all real numbers. The range is greater than the vertex. And the graph goes up all the time. So we flip our sample over. All right, one example I want to show you up here is this y equals 4x. Times the quantity x minus 10. A lot of people get confused when they see examples written in that format. You're not sure what format to call that. That is still intercept form. That's the same thing as 4 times x minus nothing, x minus 10. So you still have a p value that's 0 and a q value that is 10. So that is intercept form. You can figure out your line of symmetry, you can figure out your vertex, figure out your x-intercepts, all by looking at that. Here's kind of a real-world situation. You had a pool party, you jump off a diving board. We have our x-intercepts. So our p value is going to be -2, and our q value is going to be +5. So at -2, I have a dot, and at +5, I have a dot. This stands for time, because your x is your t value. So we're at -2, 0, and we're at 5, 0. So your line of symmetry, you could call it t if you wanted to in this case. T is going to be -2 plus 5 divided by 2. That is 3 halves. And then to figure out what our vertex is. This is a little tricky. Hang on here. This has got a little bit of math involved. Because we are going to say negative 1/2, negative 0.5. We're plugging in the 1/2 to the equation. So the equation is t plus 2. So I need 2 to have a denominator of, in this case, 2. So I'm going to say plus 4 over 2. That's still a value of 2. Then I'm going to take the rest of the equation, 3 halves, because that's my t value, minus 10 over 2. I need common denominators of 2. 10 divided by 2 is 5. 5 is the equation, so that means 5. So we get 1/2. This becomes 7 halves. This becomes negative 7 halves. So that is 49 eighths. That's a little nutty. 49 eighths. So 6 times 8 is 48. So it's going to go in there 6 times with an extra 6th left over. I hope you couldn't see that. Then that's going to open downwards and open downwards. So we're supposed to be on the diving board. It takes 1.5 seconds that we're up in the air. That's pretty impressive if you stay up in the air 1.5 seconds by the time you get to your maximum height. And then you come back down. So we have a vertex at 3 over 2 and 49 over 8. We have an axis of symmetry at x equals 3 over 2. We have a maximum value where y is 49 over 8. Now, when we talk about in context, what's happening in the problem? The domain. We're not looking at all real numbers. We're looking at in the context. So your t value could be 0. That's a possibility. But your time value could only go up to 5 seconds, because that's how long it's taking you to reach the water again, it looks like. Your range in context, it's going to be greater than 0, but it's going to be less than or even equal to 49 over 8. So how high above the water did you jump? Six times 8 is 48. So 6 1/8 yards. That's getting pretty high. Start to consider all that. What did the X-intercepts mean in the problem? Time it took to hit the water. That's what the 5 second meant. It's how long it took you to hit the water. How tall is the diving board? Where did we start at? What happens when time is 0? So 5. So we're starting at 5. So we're really not jumping all that super high off of that. That would probably be yards. So our units all match. 5 yards. Now we're going to look at writing equations. The X-intercepts are found when, our X-intercepts are found when y equals 0 in the table. The x-coordinate of the X-intercepts will be the p and the q in the equation. And the a value is going to be half the value of the second difference. So now you already know how to do this. You can handle this. Here is where y is 0. So this is your p, this is your q. So we know what our p and q are. Your vertex is right here in the middle, -1, -8. So your axis of symmetry has to be at -1. Your x-intercepts are going to be at -3, 0 and 1, 0. From 10 down to 0 is going down by 10, going down by 6, going down by 2. Now we're going up by 2, up by 6, and up by 10. They're all different. Here we're going up by 4, definitely up by 4. Now we got our second difference. It's all common. So we know our a value is going to be half of 4. So our a value is 2. So 2x minus a -3 and x minus a 1 is going to give us 2x plus 3, x minus 1. So that is our equation. This gives us a minimum value because our a value is greater than 0, where our y is, which is -8. The domain is all real numbers. The range is greater than 8, actually -8. And the end behavior, it looks like the function is increasing. All right, and this last one is for you to try. So you can pause your video and you can try that. Looking at this last question, we would want to figure out what type of equation it is. So we're increasing from -8 to 0. So that's going up by 8, going up by 4, going up by nothing, going down by 4, down by 8 and down by 12. So this is going down by 4 every time. So we have our second common difference of negative 4. So we know the A value is going to be half of negative 4, which is negative 2. We know the P value is going to be negative 2, so it's going to be x plus 2. The Q value is going to be 1, so it's going to be x minus 1. We know our X-Intercepts are at negative 2, 0, and 1, 0. That's part of our table. To figure out the vertex, we can't quite see exactly where it is. You probably have an idea that it's halfway in between here. But one way we can calculate that is to say that the x value is negative 2 plus 1. It's your P plus Q divided by 2. So negative 1/2. So your vertex is at negative 1/2. And then to find the y value at the particular point, we got to plug that back into the original equation. So we're going to have y equals negative 2. Negative 1/2 plus 4 over 2, because that makes 2. Negative 1/2 minus 2 over 2, because that makes 1 with common denominators. Zoom in here for the crazy fraction work. 4 and a negative 1 is 3/2. Two negatives, when you're adding or subtracting, they keep the negative. So we're going to look at that. This is 9 times 2 is 18 divided by 4, which is 9/2. So we know that our vertex is at negative 1/2, 9/2. It's a little crazy, but notice it can be done without a calculator. Your axis of symmetry is at negative 1/2. That's halfway in between. We are going to be going down on the end, so we're going to have a maximum where the y value of your vertex at 9/2. You know the domain is always all real numbers. Our range, we're going downward, so its y is less than 9/2. And the end behavior, the graph is going down. We're getting to negative values. The A value is negative. And in a quadratic, these are going to point in the same direction every time. Good job.